Welcoming everyone. Hey guys, anybody who is around, thank you so much for watching. This is Alex and from BellPark Horticulture. Welcome to the first Let's Talk About webinar series. So today's subject is about humidity, the unrecognized factor in the greenhouses. First, I want to thank the people from BellPark Horticulture for hosting today. They have put time and effort to create some educational webinars for all growers. BellPark has decades of experience in the horticultural industry and has helped hundreds of growers with the benefits of new technologies in the automation and equipment. The webinar is scheduled to take around 30 minutes, and we'll add some time for a Q&A session. Please feel free to submit your questions during the presentation. We'll be reviewing the questions, and unless the panelists deem it necessary, the questions will be responded all at the end. I got here, the guest host today is the team from DryGair. DryGair is the world leader in dehumidification and climate control for greenhouses and growers. And they will elaborate on that a bit more. Now I want to introduce today's panelists. From DryGair, we'll have two incredible, knowledgeable people. We got Hadar Fuchs Rubal, head of DryGair for North America region. And we got our main speaker, Yanor Yasma. She's an agronomist, works with growers to optimize the implementation of the humidification solution, and as well with DryGair. So now I'll pass on the screen to our two panelists. Yanor, Hadar, the screen is yours.
Thank you, Alex. First of all, thank you all for joining us, and thank you, BellPark, for hosting this webinar. A few words about DryGair. DryGair was invented together with the governmental Israeli Agricultural Research Organization. So there's a lot of science and data behind it. And the main purpose was to find a solution for the humidity problem that is very common, but until DryGair, it was not possible to isolate it. And when trying to treat it, cost a lot of money. Now, today, DryGair treats both humidity and temperature around the world, different types of climate, cold climate, tropical, desert areas, coast. We are working with all types of crops, vegetables, herbs, flowers, cannabis, and not only growing facilities, but also drying rooms for not only cannabis, also flowers. Basically, when the plants are still alive and still evapotranspire water into the air, we can help. And I will let Yano go from here. Hope it will be interesting for you.
Hello, everybody. My name is Yanor Yasma, and I'm working at DryGair as an agronomist and managing our markets in Europe as well as Australia and New Zealand. My background is in agronomy and focused on plant health and plant protection. And my expertise is in environmental management. And today, the purpose of the webinar is to really delve into humidity, what it is, how it is affected by other climate parameters, how it interplays in the greenhouse, and what we can do about it. We will have a short question and answer stop in the middle of the presentation, so feel free to write whatever it is that you want, and whatever we don't get to throughout, we'll get to at the end. So I'm just going to share my screen so we can get started. Okay. So when we speak about plants in any type of environment, one of the natural processes of their life is to basically give off water. It's part of the process of having stomata open during photosynthesis. We have CO2 coming in while those stomata are open, and we have water that's being exhaled. And in that water, we get a lot of good stuff. We get growing materials such as nutrients that are delivered through the root system up to the different parts of the plant. And we also get the water that's critical for the photosynthesis process. And a lot of the water movement is also directed towards cooling the plants themselves. It acts just like we do when we sweat. When the plant is heated, it's one of the mechanisms that it's using to cool itself off is to just let off moisture, and that helps cool it down to more optimal conditions. So once we're working inside of any type of growing facility, that humidity starts to collect and collect. Now, it's important to understand the concept of relative humidity. Relative humidity takes a look at that moisture that's in the air, and it looks at it in relation to temperature of the greenhouse or the indoor room itself. So what we can see is that air acts like a sponge, essentially. When we have warmer air, it has a higher capacity for holding moisture in the form of a gas. But once the temperature in the room is colder, it actually loses some of that ability, and it can hit a critical point at which the water is transformed from a situation of a gas into a phase of a liquid. And that is the point that we call the dew point. It's the intersection of humidity and temperature at which the water transforms from a gas and condenses out of the air into a liquid form, which is essentially 100% relative humidity. So we see that this happens anytime we have a combination of high humidity and low temperatures. So for example, at nighttime, we see this can be a significant issue. When we have those two conditions together, the water can no longer hold the moisture as a gas, and it will condense in the form of a liquid. So what we see is actually something very familiar to a phenomenon of taking a cold beer on a hot summer day. The surface of the glass is very cold, and the liquid that's in the air will condense into this water droplets, and the same process can happen on the surfaces of the plants. And at this point, that's where we start to see different types of problems from wet plants. This is where disease starts to take hold, and that's why we have to do everything we can to prevent this point. Now, where do we see these types of condensation? We see them quite often on different types of structural pieces throughout the greenhouse. So for example, you can see here we have wet windows, wet walls, plastics. We even have here some algae that started forming on the doorway of a greenhouse. And one of the things that we're also very concerned about is having wet plants, as I mentioned before, because that leads to humidity diseases. And another nasty side effect of having a wet greenhouse is having less radiation coming in through the surfaces. So humidity diseases are very varied. We see a bunch of different problems that can pop up in different types of crops. We have here different types of mildews and molds, which are the kind of offshoot of different types of fungi. We have bacterial infections, and we also have problems that are caused by nutrient deficiencies. So we saw that one of the things that happens is that moisture moves through the crop and it takes nutrients with it. But if we have the very high humidity, that can limit the movement of water through the plant and slow it down. And that's where we get cases like blossom end rot, for example, which is a calcium deficiency to the ends of different types of fruits. The same is similar in tip burn, which we see in different types of leafy greens. They're all kind of calcium deficiencies from having a stagnant climate where high humidity prohibits the movement of nutrients throughout the crop. So we're really working to avoid these because they have really nasty side effects in terms of plant health and yield loss. There's a lot of work that goes into trying to treat for them, whether that's through handling plants and evacuating them from the facility, whether that's spraying if that's possible for your growing operation. So we're really trying to minimize the effects of that. Now, there is a recipe for disease, and basically these three things need to coexist inside of the growing space at the same time for a certain amount of time together in order for disease to take place. We basically need three elements. I'll start here from the bottom, and that's the host. So we'll take in this case an example of a medical cannabis plant. That's basically the plant that has the capacity to become infected. Then there's the pathogen, which is a sort of disease-causing organism. So what we're seeing here are spores of botrytis. And the third thing that needs to be is the environment. And that is the environment that's essentially conducive towards the meeting between the pathogen and the host and the beginning of infection. So if we're looking in a medical cannabis greenhouse that has botrytis spores in the air, and we get to a point of essentially high humidity, the wet plant will be an area where basically the pathogen can start to develop and penetrate within the plant itself. That's where we have infection, and in this case, this is bud rot in medical cannabis. So when we look at growing conditions, we're going to have the host plant. That's basically the plant that we're cultivating. That's a given. And when it comes to the pathogen, as much as we try to kind of perk up on hygiene mechanisms and protocols, and as much as we will work with maybe some type of air filtration system, at the end of the day, there really is no environment that's 100% spore-free. And that's why when we look at how we can manage these types of conditions, we like to focus on the aspect of the environment. And when it comes to humidity control, what we target is humidity reduction in order to not get those wet plants, and also to increase the air circulation throughout the growing space. I'm going to take a pause here just to see if until here everything was clear, if there's any questions. Yeah, I see here that we have a question. Are disease-resistant plants still susceptible to humidity-related diseases? Very much so. I think that there's a lot of work being done to kind of advance how resistance can play up as a kind of factor to help mitigate the effects of humidity diseases and all kinds of diseases. But at the end of the day, unfortunately, a lot of the plants are prone to a variety of different conditions. And while resistance helps us improve the mechanisms for the plant to defend itself, there still tends to be, at the end of the day, a high risk involved, because we have basically a facility that's with really intense cultivation, and it's all kind of under the same conditions. So if we do have an instance where disease starts to take hold, once we're working in that highly intense cultivation type of layout, with a lot of handling, with a lot of really dense crops, we tend to see that, it's enough for one pocket to kind of get started, and then that will really spread throughout the greenhouse like wildfire. So resistance does get a step closer, but it really depends if you're able to really find the variety that's also commercially viable, but has resistance to the multitude of different potential diseases that might affect your target crop. I think it is an improvement, but I don't think it's foolproof. I think another important aspect to take a look at is that essentially humidity management is a lot about disease proofing, but it's also about keeping a healthy and active plant. So if we get a stagnant climate because of high humidity, we might be hurting the potential development of the plant itself. So it's another thing to take a look at. Second question I see here is, how does the airflow impact positively on the environment? How does this important reflect? We're actually going to get to that in just a few minutes. It's a really great question, and it's incredibly important. It has to do a lot with the physiology of the plant itself and what we call the boundary layer of the crop, which is essentially an area that kind of controls the flow of moisture from the crop into the air. So good airflow will keep that boundary layer moving, so we can help increase the movement of water and not little stagnant pools of water around the plant surface. But also it has a lot to do with creating an equal climate throughout the space in order to kind of mitigate those pockets of trapped humidity that we were discussing. Okay, we're gonna keep going now, and we'll be able to pick up any more questions a little bit later on. So I'm gonna get into, we discussed a little bit more about the problem, and in the second section now, we're gonna talk a little bit about the different possible solutions for how to manage humidity. And we're first gonna talk about what's kind of been conventionally done until now, because it's more or less kind of the only thing that was available. And that's controlling humidity through playing with temperature and ventilation. So temperature can help us reduce humidity because, as we said, if we have warmer air temperature, that air can hold more liquid in it, and then we're getting farther and farther away from dew point. So we can heat in order to lower relative humidity. I think the negative aspect of that is that we still have to maintain the optimal crop conditions. We can't keep heating and heating to lower humidity, because at a certain point that will be too hot for the crops. And it's also important to note that heating triggers a response in the plants as well above a certain point where they're too hot, and then they start creating more humidity in order to cool themselves off. So there's a limit to what we can do with temperature control. That's very common to do humidity, but now we want to make sure that we're controlling basically the amount of temperature. So we'll open the windows. We'll use that in order to expel the excess humidity outside. And then on the way, we're also throwing out that hot air. In a lot of cases, what ends up happening are these sort of cycles where we're ventilating in order to release the extra humidity. We're dropping in temperature, and then what we need to do is invest heating energy in order to get the temperature back up to the right plant and cultivation temperature. So these are kind of wasteful cycles of heating and ventilation. And it leaves us with two kind of bad options. It's either we close the greenhouse and then we have the problems of high humidity and wet foliage and diseases, or if we're using this type of night ventilation, we end up wasting a lot of energy. I do want to add that another kind of negative side effect that comes from these types of systems is that we often see there tends to be a sort of gradient that happens throughout the ventilation process, where we have one area where we're getting input air that's coming in usually colder and with lower humidity, and at the end of the greenhouse we have the output area where that's collected all the moisture and the heat, and that will have a hotter and more humid kind of profile in terms of the climate conditions. So we end up getting a lot of variation, which isn't good for crop consistency. And I think the third thing that's really important to mention in this case is that when we're using ventilation, we're dependent on whatever conditions we have outside. So if it's a cloudy day or a rainy day, or if we have very, very low temperatures, we're putting that air into the greenhouse, and then we have to activate a lot of mechanisms to try and compensate for that. Or in the case of days where we have high humidity outside, the ventilation is not going to be effective because there won't be enough kind of dilution power to move the humid air back outside. So that's kind of what has conventionally been done. We're going to go through a few of these different types of dehumidification methods to give you a more full picture of how this happens. The first is heating, which we just discussed, and that can lead to a waste of energy. And oftentimes we also see that even in the summer, for example, we will have growers that will be heating just to help treat for humidity when we're definitely in a season that doesn't require heating. I'm going to move on to air exchangers. And these are essentially different systems that are sort of facilitated ventilation. So you can see, for example, in this image, there's a fan that's placed at the level of the screen. The window is cracked open, and we have the outdoor air that's coming into the greenhouse in order to mix with it and kind of try and equalize the climate and remove humidity. In this case as well, as we mentioned in the previous slide, you're relying on outside conditions. So that can be questionable depending on whatever weather you have outside. And also by breaking basically the isolation of your greenhouse, you're having to eventually end up also reheating the greenhouse in case you have lower temperatures outside. And when we're talking about crops, for example, that have a light regimen and work with blackout screens, the option of ventilation can sometimes be tricky to do because we don't want to have any light pollution going in, or the opposite, if we're using grow lights inside and we're trying to prevent light pollution from going out, we don't want to have any type of situation where we're getting light in or out that's going to hurt the production. So those are also another form of basically ventilation in different formats that are facilitated by usually some type of fan. The third type of solution is basically we're crossing over into the world of dehumidifiers. And for the most part, these systems work on, instead of relying on outside conditions, what we're going to do is actually close the greenhouse and work with what we have inside. So we're going to first talk about desiccant dehumidifiers. And a desiccant is essentially a type of chemical that has properties that allow it to absorb moisture. So you might be familiar with desiccants from those little packs that you will sometimes see inside of a new pair of or electronic equipment. They have the power to basically absorb moisture, and that is what we're doing in a situation of a growing facility. So what they do is that they treat the greenhouse air by coming in contact with this chemical. The chemical will then absorb the moisture from the air into itself. And in the second stage, what ends up happening is because that solution becomes saturated, we're absorbing more and more moisture, we need to find a way to expel that moisture so that we can replenish the chemical and be able to use it again. So what we have to do there is in the second step to dry out that chemical, and that's done by applying heating. So we have to reheat the chemical in order for the system to be able to continue to work and keep moisture down. And that brings me to the fourth type of dehumidifier, and these are refrigerant-based dehumidifiers. So the way they work is very similar to an air conditioning system or a refrigerator. What we have is usually a compressor inside that's running a refrigerant gas inside, which goes through a process of compression and expansion, which at the end of the day creates a cold surface. And that cold surface brings us back to the dew point. We're actually creating a sort of dew point magnet, cooling down the air in that surface, and the humid air that meets that surface will actually condense the water that's onto it, and that will be basically collected and taken out of the greenhouse. So that's the type of system that we work with in DryGair, and we've seen some very positive results. Now I want to get into, a little, okay, there are different types of how do I approach this question of what to look for when I'm looking for a dehumidifier for my facility. And there's a number of parameters and guidelines to help figure out what the right thing is for you. So first of all, we take a look at water extracted from the air. I'm bringing in a system to remove moisture. How much water is it actually removing? So what we have here, for example, is a cannabis greenhouse that's working with the DryGair system. And you can see here that the y-axis here is showing relative humidity. And what we see is that while outside we have relative humidities of about 85%, inside once the black screens were activated for this facility, so we're looking at from about 6:30 p.m. until 6:30 a.m. The dehumidifier is constantly working and keeping humidity just below 60%. And we can see how much water is collected throughout the night. So we see that in this one night, the unit was able to take out 520 liters of water. So what we need to look at is what type of extraction capacity am I able to get from my machine? How much transpiration does my plant produce? And will that piece of equipment be able to handle that amount of moisture and make sure that it's taken out of the greenhouse air so that we have the right conditions? It's really important to understand that humidity is part of a huge balance, and there's a lot of parameters that once you affect one, they kind of end up affecting the others. So in this case, we're taking a look at the different crop types and what conditions they need, because it really makes a difference. So what we look for when we're picking out a dehumidifier is, can it reach my target relative humidity? Different crops have different conditions, and that can often change also with the different stages of development. So if we take a look at the basil greenhouse in Germany, their target was 75%. Basil is extremely sensitive to a type of mold that's called downy mildew, and they need to keep within that range of 75%, more or less, in order to get good control. So we see here a system, two different greenhouses, that one is using the DryGair system. You can see the results in green, versus a control system, which is that traditional system of heating and ventilation. And you can see that we're getting consistent control of 75% throughout the different seasons, while here we have issues reaching the target in the different seasons with the other solutions. So you have to make sure that you're going to be able to get the conditions that you need. Alternatively, we'll take a look at a cannabis greenhouse, and that's a completely different crop. And we see there that, you know, there's a lot of variation in required relative humidity, but we tend to see that a lot of people work between 60 and 70%. And we can see here that by keeping within that range, they were able to finish the growing season and not have any botrytis. And that's really what it's all about, is being able to prevent the crops from getting sick. So we want to make sure we can reach the required relative humidity per our plant, per our facility, per the stage of development. Now we're going to get into a little bit about the previous question about air circulation, why that's so important. We're looking at a very dense cultivation whenever we're taking a look at greenhouses or indoor facilities. And we have a lot of moisture that's always being produced by the plants consistently. And that needs to go somewhere, because if not, we're going to get stuck with it inside. Now, when we don't have good airflow in that type of intense cultivation, and we end up having places where humidity collects, those are basically the kind of initiation sources of infection. Any type of wet pocket inside of the greenhouse is a microclimate where disease can start to take hold, and that's where everything begins. Once we have one sick plant, it's very easy for his neighbors to get sick, and that can really spread like wildfire throughout a greenhouse. So we're really looking to have good airflow in order to equalize the climate throughout the greenhouse, mix the air as much as possible, and make sure that nothing gets stuck. You can take a look at this example of a pepper greenhouse in the Netherlands, and we can see here in the central picture, we have basically a DryGair unit here that's sitting inside of a greenhouse that's with fully mature pepper crops. These crops are about 4 meters tall. And you can see when the unit is off during the daytime, we have a lot of variation in the temperature profile throughout the plant. And wherever we see a cold pocket, that's again a place where we run into the danger of hitting dew point, because that cold can become that source where moisture will start to condense. And if we compare that to here, when the DryGair unit is running at night, we see that we get a much more even climate throughout the crop. And by preventing those more microclimates, we can prevent basically the onset of disease. So as much air movement as possible. The next factor that's super critical to look into is basically energy efficiency. Cultivation systems can be pricey operations with a lot of different factors that need to go in. And when you're looking at dehumidifiers, it's important to see how you can do leverage a solution that not only takes care of your moisture, but does it in a way that is energy efficient and energy saving. So this is another greenhouse using a DryGair system where we're comparing basically a double pipe system. They're growing gerberas and they have pipes on the floor level and then pipes through the crop level. And when we compare DryGair versus the conventional ventilation and heating, we see there's a drastic difference in the demand for the temperature of hot water that needs to be delivered to the pipes in order to achieve the target temperature inside. So basically, by being able to work with a dehumidifier in a closed greenhouse and keeping our resources inside, we're able to save a significant amount of energy. And when we take a look into the heart of the dehumidifier itself, it's also really important to understand what its efficiency is. So the way that we measure efficiency for a dehumidifier is by comparing the amount of water that it's able to extract from the air to the amount of energy that process consumes. So our advice is to look for a system that has a very high ratio. So we're speaking about 1 gallon per kilowatt hour or higher. That means that you're using a system that's energy efficient, you're getting your money's worth, and you're saving energy. It's definitely important because it takes energy to make this process happen. So we want to make sure it takes as little as possible to get the biggest effect. It's also really important to make sure that your solution is localized and relevant for the facility you're working in. Different solutions might be better fit to different type of climate regions. If you're in a colder area versus a desert area, your inputs and outputs, your conditions are going to be different. So you want to make sure that that's going to work well. And when we look on a local level, we want to also make sure that that solution is relevant and viable also throughout the different seasons of your cultivation. So it's always something important to look into and make sure that that's going to hold you over and enable you to do the growing season at the length or at the year-round level that you're looking to get out of your facility. And I think another important thing for all of us is to make sure that that system is with a simple integration and maintenance. You know, there's a lot of moving parts in a greenhouse, and I think it's important to make sure that that fits in sleekly and well with whatever operation it is that you're working with, whether that's having the ability to connect to a climate control system so that you can orchestrate all your elements better if that's how you work, or whether that's you know, having a good air circulation built in that doesn't require heavy installation and maintenance and costs. We want to make sure that we're basically putting in a simple solution that's going to make our life easier instead of more complicated. So we look for products that are more plug and play, fit well into the space, and are easy to use. So I'm just kind of going to sum up and explain that, you know, I showed that slide previously with the different type of balances. And one of the things we're learning all the time is that dehumidification is at this kind of interconnected web of different climate parameters and different growth parameters in a greenhouse. With a good, effective dehumidification strategy, you can prevent disease and reduce the need for pesticides. You can boost your nutrient uptake to get a healthier plant. You can have better air circulation, which can lead to greater uniformity and consistency of your crop. You can see significant energy savings by just being able to work in a different way, and, you know, energy savings. And a lot of times what we're seeing is also CO2 savings. By working within a closed greenhouse, you're able to actually keep the CO2 you work with inside instead of having to have it come out of the window along with your humidity. So it's another big bonus. And of course, we also get a lot of water from this process. The plants are like giant pups that are always throwing water into the air. And if we have a way to harness that, collect it, remineralize it, and send it back to the plants, that's another resource that we were able to reuse within the closed system of the greenhouse. And, you know, for the bottom line, the idea is to get higher quality and quantity yield and do that in a way that is with lowered costs. Another interesting thing that we happen to see now more and more being talked about is this issue of vapor pressure deficit. So VPD is kind of a measurement of you know, how nutrients are moving and water is moving throughout the plant, and we want to be always in kind of an optimum range. When we're in lower relative humidity levels to a point, we can have better VPD for our crops, and that leads to more active plants, more production, healthier, better quality. And that's another interesting thing that we've started to receive as feedback, and as you know, more growers start to steer growth through VPD. So I'm just going to summarize what are the things you should look for when you're looking for a dehumidifier. We're going to make sure that we have a high water extraction rate to make sure that we're able to really get rid of the moisture that's in there that we need to get rid of. It needs to be able to reach the required relative humidity as specified by our crop and our growth and what we're trying to do. We want good air circulation in order to create a consistent growing climate for consistent crops, and also to prevent any type of trapped humidity, which can be the onset of infection. We're looking for high energy efficiency in order to minimize not only our expenses, but also our footprint, and minimize our costs. We need to be suitable to the different climates and seasons that we're growing in. And last but not least, to make sure that the integration and the operation of the system is simple and makes the life in the greenhouse, you know, a little bit better, improve quality of life at work. So with that, I've ended my part of the presentation. We'll open up to the Q&A and see if you guys have anything that you would like to discuss with us. So I see here a question from David, why does DryGair use testing conditions of 64 Fahrenheit at 80% relative humidity when other dehumidifiers use 80 Fahrenheit, 60% relative humidity? Is one better than the other? That's a really great question, David. The standard for dehumidifiers in the past has been 80 degrees Fahrenheit, 60% relative humidity, because that's the standard for working within industrial conditions. So, for example, if you are working within a warehouse or a commercial building, those are kind of the go-to conditions for that type of environment, and that's why a lot of systems had kind of catered to those conditions. A lot of the dehumidifiers have kind of come out of that type of market and then transitioned into agriculture. DryGair uses testing conditions of 64 Fahrenheit, 80% relative humidity, because those are the crops, those are the conditions that the crops see. When we're looking, for example, at kind of average nighttime conditions, for example, for a tomato crop, that's going to be more or less the conditions and the target that we're going to look for. And that's why we test at those conditions, and that's why we design our product around that condition, because that's really what the crops are going to be producing. The system is designed for agricultural environments and a type of constant source of moisture that's being released into the air. That doesn't happen in an industrial application or a commercial application. Here we have a very different balance, and DryGair works to cater to the plant conditions, which we'll see in agriculture. I also see another question. How to maximize the DryGair operation versus location in the greenhouse? Can it be installed anywhere in the greenhouse? So I'll take just a minute to explain a little bit about our product. We basically have an air circulation that comes from one central point and is distributed kind of evenly throughout the greenhouse. So you can see here that there's two fans that are at the top of the unit, and those inhale the humid air through the two sides of the unit. The water is condensed onto that surface, and then it gets reheated and blown out at the top where it hits this type of roof shape. And that air is thrown out in 360 degrees around the unit for a radius of about 30 meters. I'm not so good with the meters and the feet, so maybe someone can help me out with that. But we get a very large reach for the unit, and that's why we choose, you know, if it's up to us, we'd prefer to have the units spaced centrally, because you get air circulation to all different directions, and that really kind of maximizes the uniformity of the climate. But of course, there are different types of setups and different requirements, different shaped greenhouses, and we also have options for working with the unit if you need to place it on the side of the greenhouse and blow air in one direction. Or you can see here, this is a split unit, which is working in setups with rolling benches, for example. So we have the upper part of the unit up here, and this is the lower part with kind of the moving parts. So we can actually slide the rolling bench over that part, and it can kind of sit up there without getting in the way of anything. So there's different applications. If it's up to us, we prefer to have it in a central location as possible.
You have a few more questions?
Yep, I think Hadar, there is one question that came in through the chat. Do you want to take over that one?
Yeah, we were asked what is the acceptable amount of water per area that needs to dry up in the cannabis greenhouse at the peak season of growth when the whole greenhouse is closed at night, from Eran Alon. So it changes, of course, from greenhouse to greenhouse and according to the growing methods, but basically, like the thumb rule, we recommend our DG12 that is designed to remove 12 gallons per hour, up to 10,000 square feet in a cannabis greenhouse. So that can give you the range of water removed needed in the greenhouse. I do want you to answer one more question from Edwin. Can you see the question?
Yeah, elaborate on how DryGair supports CO2 enrichment. So as I was saying, our system is designed to work within a closed greenhouse. You close and seal off the greenhouse, and you're working to treat the air inside. And once you close the system, whatever CO2 you have inside can stay inside. And when you compare that, for example, to systems that rely on ventilation, we lose a lot of CO2 because we're opening the windows to have it come out. So if you're enriching, you're making sure that whatever you're putting into the air stays in the air. If you have, some type of ambient CO2 in there, once you close it, it will stay inside. So we've seen cases, for example, where we can double the amount of CO2 inside of the greenhouse compared to a ventilation and heating kind of a system, because we're able to close the greenhouse and keep the resources inside.
Another fact about the CO2 is that you can benefit in cold nights. You can benefit the CO2 from the photosynthesis happening during nighttime. So you can keep the greenhouse closed for a few more minutes, and you can just benefit the CO2 from the plants.
Okay.
And one last question, is there an advantage?
Is there an advantage to one DryGair dehumidifier versus some small dehumidifiers? It's an excellent question. There's a lot of different types of units and modules that are out there on the market, and there's a lot of smaller models that maybe have been conventionally used for more smaller scale growers that are now, viable options for large scale cultivation. I think that the advantage of DryGair compared to a small dehumidifier is that you have kind of a one-stop shop. You can cover a very large area with one unit. And from what we've seen, it also ends up amounting to less energy use, because instead of operating 5 or 6 small systems, you can use one system that's very efficient. And I would say that I think another issue that we've seen with small dehumidifiers is that they tend to not have the greatest solution for air circulation. A lot of times they require either some kind of ducting, which is kind of an added expense and maintenance, or they will end up kind of treating a localized area, a small area, instead of really being able to mix the air and get a good climate throughout the space. So I think those are good things to look at. We mentioned, the water extraction rate, the energy efficiency, the air circulation. Those are all things that you should always take a really good look at when you're trying to pick which system works for you.
Okay, I guess that that's all we got the time for today. First of all, I want to thank the team from DryGair, Yanor, Hadar. Thank you so much. I appreciate the time and effort you guys put a presentation. Fantastic. I hope that everybody got what they're looking for. This is the end of the webinar, first webinar. Let's talk about Sirius. And again, I want to thank again the team from DryGair, BellPark Horticulture. Thanks again for hosting. Panelists, again, thank you so much. All the viewers that have joined us, thank you, great. All the viewers that joined us today, hey, please, we encourage anyone that has any questions regarding this webinar to message us, info@bellparkhort.com. And this whole presentation will be made available online in YouTube through our website at BellPark Horticulture as well. Thanks again, everybody, and hope you can join us for the next webinar. Thanks again, guys, and have a great rest of the day. Take care.
Thank you.
Bye.
Thank you. Bye.